Hello everyone, just want to go over this week's assignment for this week. And so this week's code, I wanted to show you guys just a review for those of you who are not in class and overcoming illness. We have a new field with objects, and if the car hits an object, it plays a sound and puts the car back off in the object. And if the car runs into a brick wall, then it will simply say, you hit a brick wall and you have to start over, adding to your time. So that's what this does, but we had to do something here that was really unique and interesting, is that the graphic and the data actually had to match. And so the question is how do we get data and graphic to match perfectly? Well, the way we did that was with Excel. And here's an example of Excel. Every cell inside the Excel has a value inside of it, and we just took the color function and just said we can make the cells any color we want as long as all are the same color. They don't even have to necessarily be any particular color, but then we can take massive amount of cells and copy them, and if we want to, when we're done, we have a bunch of cells, and each cell will have a position, as you can see there, and a value. And as we move the cursor around in the cells, you can see that that's value of 1 and that's value of 2. So we can draw a field, and then we can just simply use the Excel function to shrink down, and now we have a graphic. Okay, so there's a graphic that we could grab in, but then we can also save it as an XLS, but we can also save it as a CSV. But what a CSV does is only save the data. And when we only save the data as a CSV, then what we end up with is the ability to have a comma delimited file that looks like that. Now what we did here is I took the entire field here with Excel. And I took it, and let me grab the other Excel here. Let's shrink this down. That was off. My other Excel is this Excel. And as you can see, this is pretty much the Excel for the court. And if I click on the fields are, the boxes are really small. Okay, so we were able to use an Excel spreadsheet. We had our CSV data, but now we had the issue of how do we get the CSV data that we want into an actual array? Well, what we did is I wrote a little test program here, and what we did is we defined an array that was roughly 1200 wide and 800 deep. And if we go back in here and look at the Excel spreadsheet just real quick, this one, you'll see that the bottom row here was about 780 or lines long. So we just made the array a little bit bigger than the field. So when we did that, let's see. So we define an array, and we use a new function. We use two new includes. We use sstream and fstream. And what these do is sstream allows us to use the ifstream command, because we saved the CSV data for the Excel spreadsheet as base.csv out into Notepad. We edited it and made sure it was good, and that's out there in the class drawing. So what we have here is we open up the file, and then we get a line of data. So we're getting the first horizontal line. So we're going to flip through this and read in all 786, 87 lines. That's what we're going to read in here. And then we're going to count as we go down. I is our counter as we go down. And then what we're going to be able to do is we're going to be able to parse through. We're going to get the length. Remember, we're moving the line into the line of data into a string that we call line. And now we have also a string called text. And so we're going to say text is equals to line substring j times 2, and j is starting out at 0 as we walk down the line. So the first time we do it, j is going to be 0, so we're going to get that position. The second time, j is going to be 2, then 4, then 6, then 8. So we're going to be skipping all the commas. We can kind of play that game because we know exactly where the data is. Every number is exactly one digit, and so we're good with that. So, and then as we go through j, you notice that field j is the row, right? J is a column this way, going out this way, and there's 1200 that way. So we're going to go down and get the length, and we're also testing to make sure that before we actually do the actual text, the string to integer conversion of the field and put it into the array, we're going to test to see if it's 1, 0, 2, or 3. And we finally got this to work. And my test data is I'm going to slice through I equals 370. If I equals 377, I'm going to show you all the j values going across. And so I'm going to go through at 377, at I equals 377, which is going to be right in here. I'm going to find this hay bale right here as I go through there. And so we're going to go back to our output, and we're going to see what we output, and yikes, where's our output? So if I equals 377, then do that, and I say run, and where's our output? There's our output. So we're going down 1186 characters. And if we go in here and look and we see a blink, there is the belt pay, there's the 2, there's the red line on top, there's the 1s, and there's the red line on the bottom. I knew that was there, I knew that worked. So that's what that looks like. So what we did is we wrote this in console first as a main. Well, what we ended up doing is taking that apart, and we created what's called a load field array. And so you can see that I moved the variables inside, but notice that the XY, that the actual array in XY, in using namespace standard, all this stuff has been moved into the top of the program. And I'm using my compression thing so you can see me do this. So I put those there, and then I went ahead and added the field array there. So then what we then did is we got a screen grab with bitmap. And I think this is about it. Nope, we still have time. And so we got a screen grab with bitmap. And so we created a bitmap. And so we loaded, if you look here, we loaded in, when we load images, we're now loading in a new field that is also out there in bitmaps called field2.bmp. You'll find that out there, and then we're trying to do some other things with the car and the green background and some other stuff like that. But we had to get the car on top of the field. So to get the car on top of the field, when I defined the field here, let me close this back down. So the issue is, you'll notice that the car is on top of the field. So yes, we got the bitmap from the Excel spreadsheet. When we put the bitmap into Paint, we made sure it was the same size as the array. So every pixel in the array is exactly as is in the bitmap. They're the same size. So the thing is how did we get the car on top of the field? Well, this window here, the big window with the X on it, so this is HWND, and then this is field, but this is car. So you'll note that when we go down, we had to create a new handle for field. So you'll see a new handle up there called hfield. And then we'll come down here and add controls because we paint the field for, or what is now our first and only field. We paint the field right now for H field. But notice that for H field, the parent is HWND. So the parent for the field is this window here, which that makes sense. But then field, if we come down here and look at Let's Play Knit, when we draw the car in Let's Play Knit, we notice a handle H car in the parent window is H field. And so that's saying, so we have HWND, which is the parent to field, and then we have field that's the parent to car. So H car. And so, and then you'll notice that I put the finish line still out to the side, and it's sitting on top of HWND because that's all I need to worry about. So that's the order. So the next thing we did was we had to load, not only did we load the array, but when we load the images, I went ahead and loaded the array and the image together. So after we do the H, bring in the new field 2 bitmap, which is out there in our bitmap images on Dropbox. I did the load field array, and you'll have to include this field2.bmp and this base.csv in your project for these two things to, and also note that we did create the new function up here for load field array on top. So that's where we defined it, and then we actually executed it inside of the actual load images. So once we get all that put together, we have our directions and stuff like that. So we have all that put together, but now we created one. So we have a new field, and we've loaded the field into our new array called field 1. We had to create a program to read in the CSV file. We've included the new bitmap into our file, and we've now loaded the field in. We've also created a new handle for field, and we've made field the parent of cars. So those, but now we have this thing called Checkobjects. Notice that Checkobjects has an integer. This is a new function. Must pass into direction so we can calculate delta x and y. So it returns in since x and y are global, we're just going to increment x and y based upon what Checkobjects says. So we pass in a direction. So you'll notice here, when we look in our callback routine, is we'll actually go in and through all of our WM key down, and we'll do the left and the right and all the 8 directions. And before we do a Let's Play refresh, we'll check objects. Now that we've calculated our new x and y based upon the direction we've moved, did we hit something? So we're going to check objects. Well, what does check objects look like? Well, check objects is pretty simple, sort of, and I have a couple examples here in check objects. And that is check if we won. That's our first one, and we're checking if direction is 6. And then notice that the car is about 100. Notice that the car object, which I'm going to use this one, notice x and y at any one point in time is this top corner right here. So if I want to know if, and even though this has a green background, if I want to know if I hit the car, then I need to know is that point there plus 100, which is the front bumper, going to hit the hay bale? That's what I need to ask. Actually, it's 110. So you'll notice I take x plus 110 plus y plus 50 is equal to 2, because I'm checking to say, did I hit a hay bale? If it's equal to 3, then guess what? I know I hit the finish line, right? So I'm saying check if we won, and if we won, I give a message and say, hey, you won, and I reset x and y and say, play again. Eventually, we'll move them on to a new level, but we'll say, go ahead and play again. But notice if they hit a hay bale, I'm saying if the direction is 6, because I have to check for every direction and calculate, like if I'm going this way, I have to see at the front of the car. So out of these 3 possibilities here, we can win, we can hit a hay bale. And notice when I do hay bale, I'm doing direction 6, which is going this way, that I'm checking 3 sensors across the front of the car. If this is X, now remember going down is the Y, and so I'm saying going out to the front of the car, notice I say X plus 110, Y plus 50. So I'm going down 50, and I'm saying 110, Y plus 10, 110 plus 90. And notice that these are ORs. OR and OR. Okay, that was an OR there. I hit Control Z. Okay, and so I'm ORing those. So if it's 110 plus 50, 110 plus 10, so I'm checking, is it here, here, or here? If any one of these hits the hay bale, then boom, then we'll look inside the array, which is matching the bitmap at this time. If the array returns a 2, which all this green stuff out here is 0, then what do? We say x is equal to x minus 40. What if we're going the other direction? Well, we got to bounce back the other way. So what if I'm going this way? And the white square will really help us. Again, I hit the hay bale and I bounce back. You see that? All right. I could probably pick a better sound. But so if it's 4, notice that I'm adding 40, moving it in the positive x directions, which is moving it back away from the hay bale. So direction tells me what the direction I'm traveling tells me my reaction. And notice that I know that since x and y are the front corner, it's x plus 0. The offset is 0. Does that make sense? So x plus 0 is x plus 0. That's this front edge. X plus 110, that's the back edge. So if I'm going the other way, then that's plus 110. So that'll give you an idea of how you have to walk through these. I gave you 3 examples right here. And then if you're going down, the hay bales are skinnier. And if we're going down, then we notice we need more sensors. So I put sensors at 20, 40, 60, 80, 100, and 100. And then another one at 50 because I just hit 6 sensors. And then it's going to bounce back up. So that's just how that works. All right, guys, last video. I just want to go over this one more time. In Dropbox Echo Computers here, I just want to show that your base.csv and the XLXS are sitting after the base.csv you want to include in your project. And in the actual WAV files, not the WAV files, but in the bitmaps in here, you'll see that you have yes, you will have a field.bmp and a field2.bmp. If you open that up, there is the BMP of the actual field. And it's the exact same size as the array. There's actually some other images in here too, and I've been playing around with the backgrounds and trying to get transparent images working and some other stuff too. Also, you'll notice that out in Documents, Class Docs, and if you sort by date and time, Echo Computer Class 218, which was this Tuesday, let's just go over some of this code. Now, the actual code for the include is there. Of course, you have to say, use your standard output and stuff like that. But I gave you the entire load field array function. So you need to still define it in the top of your program. You still have to define the array, but this you should be able to cut and paste and add to your program pretty much as is. It might need some reformatting, but this will load the base.csv file. So it's right here in the file. You guys can cut and paste it. Now, also Checkobjects, I also gave you some sample code for Checkobjects, just so you guys can have a good feel of what Checkobjects is. The project this week is where you use class Win05, which I put out there already, and that's a typo. Class Win05 is in Dropbox Access Computer, so that's last week's project. If you have Excel, you can make your own field. So if you want to make your hay bales bigger, if you want to take the base, the field 1 or field 2.bmp, you can also take that and like change your hay bales or change your brick walls, or to make it look more fancier. It just gives you a data representation of, just make sure your bitmap is the same size as your array. Add the load fill array to your code, make sure to add base.csv to your library, and also I didn't put